So when we look at confidence intervals for proportions, we're going to be back using our z-score, and we're going to be doing part over whole. They'll do one of two ways. They will give you the x value, like for instance you had 12 yeses out of 29 people. You set up your proportion 12 over 29. Or they will give you a percent. 32% of your sample of 600 said yes. So you may need to find, if you use your calculator, you may need to find the x by figuring out what is 32% of 250 people, or 600 people, whatever I said. So there's two different ways to do this. And your calculator, again, has a great step for the one proportion z-test. And we'll find that as soon as we hit one of these. Most important is developing your p-hat. Now, your p, here's your population, here's your sample. Just as we used the mu letter for your population and the x bar for your sample, we use the sigma, the little sigma, to be your standard deviation, and an S to be your standard deviation for your sample. We use a P for proportion for your population. And because this, for some odd reason they don't have another symbol, they use a P hat. They call that little symbol a hat, and we read it P hat. So the P hat just means that's from your sample. Yeah. And we do the same thing. We're inferring information about your population proportion based on what you found on your sample. That's why we do the whole confidence interval thing. Your point estimate for your samples were these guys. You used a sample mean, you used a sample standard deviation, you used a p-hat. These are your point estimates. So for this guy, we're just developing a p-hat. Because P and Q add up to 1, normally you do this. So you do the same thing with your sample. 1 minus p-hat, this will give you q-hat. So remember that when you do this part.
So
Don't worry about it, Conrad, I didn't even take a chance yet.
So samples is all about hats.
Set hats. You're right up your alley here for you, Darian. Right up your alley. Okay, so if you take a look at this, the first time through, they're just wanting you to find a p-hat. Okay, so if you take a look at example 1, in a survey of 1,011 U.S. adults, this is your N, this is how many people you surveyed. Are there more than that adults in the United States? Yes. So this is your sample. Your sample size, your N. 293 said that their favorite sport to watch is football. This is your X. Out of the 1,011 that I surveyed, 290 people checked off football is my favorite sport to watch. Find a point estimate for the population proportion. Your population proportion is P. Your point estimate is p-hat. So p-hat says take x over n. Just build a proportion, part over whole. That's all it is, like you always did your proportions. For percent, proportions, part over whole. So you do 293 over 1,011. And you can leave them in reduced fractions, but generally, if you want to flip this to a percent later, give me 3 decimals. Rule of thumb, 3 decimals. So you just put it in your calculator, 293 divided by 1011, and you come out with 0.290. Now the reason we go 3 decimals is because if you flip it to a percent, or percent of my population is this, and you move this 2 decimals, you want to have 1 decimal there because it's not exact. It'll never be exactly 1, exactly a 0 that way. So this one came out this way, if you flipped it to a percent, if for some reason you need it to be a percent. Okay? But rule of thumb, 3 decimals. So all we're doing to find your p hat, your population, your proportion for your sample, is to do x over n, part over whole. So you guys try yourself 1 at the bottom of 303. You're going to find this is very similar to building a confidence interval for your population mean. This is very, very similar for your z-score population mean. Okay, so what's your n? N.
385.
Okay, 3859. What's your s? 1177 said that they think all the presidents that Roosevelt was the greatest. Find a point estimate. A point estimate is your p hat, x over n. So in 3 decimals, then what'd you get? 0.305. Good. So to find a q hat, we say 1 minus your p hat. Great, thank you. 0.695. So now we have your p hat and your q hat. It's the same as your q and p, but remember, q and p is your population, q hat and p hat is your sample. You don't know the whole population, so if you do a sample and you build your interval for your sample, you're going to be that percent confident that your population proportion will fall between those numbers. These are inferences we make about your population because we don't know what the population proportion is. So we're making inferences again. Okay. Now, to build your confidence interval, it's the same as you did with your mean. Your mean point estimate was this, and you did this. So now, for proportion, this is your point estimate, right here. So therefore, you build your confidence interval based on your point estimate, plus or minus the margin of error. So again, you do the proportion minus the margin of error. This is your population. And the point estimate plus your margin of error. This builds your range, and you can also do it like this. Do those, the same thing, the interval. And you're being X amount of percent confident that your population proportion will fall between those. Again, it's much easier to find an interval of data than it is to be exactly at one point. So that's why we build the interval. Now, your margin of error formula is different than your other one. Your margin of error formula before was your ZC, standard deviation, over the square root of n. That was for when we did your mean, your population mean we were looking for. When we're doing your proportion, this is your p hat, q hat. Notice you don't know a population standard deviation, or do you know the sample standard deviation? No one gave you information about that. So we're going to use our p hat and q hat, and we're going to put it in this thing. We still need your ZC. Your ZC stays exactly the same. And an easy way to remember that this is not the same as the other one is because you're finding your p hat, your q hat. You got to use it for something, right? You should be able to use that. You have no standard deviation here, so you're going to use this instead. God bless you.
Thank you.
Okay, so now, God bless you.
Thank you.
We're back to testing. Because we're using N's and P's and Q's, we're back to testing. We're back to that binomial type of testing here. But what we're going to do is we're making your curve approximate a normal curve. So remember way back we saw those different graphs and we said when NP was greater than 5, equal to or greater than, it approximated a normal curve. We're going to just have to do these tests again to make sure that this approximates a normal curve. This is why you do this. We need to make sure this is first. You know how they always say, assume that it approximates the normal curve. We have to do the testing ourselves. So let's take a look at this. It pretty much runs the same way as your other one. So to build your confidence interval, you're going to identify your statistics that you need to use. That's basically your N and your X. If they gave you a percentage, you're going to have to then find your X and your N if you're going to use your calculator step. If they gave you a percentage, that's your P hat. So if you use the formulas, you don't need anything else. You're going to test. You're going to find your ZC, same way we did before. You're going to put it in your margin of error formula. You're going to build your confidence interval. So it's kind of a nice way to come back from vacation, because had you forgotten this over the week that you were having fun and enjoying your lives, you can kind of hit you back in the face over here. So let's try one together. Example 2. Example 2 on page 305 says, construct a 95% confidence interval for the population of adults who say that their favorite sport is to watch football. This goes back to example 1. So if you remember example 1, we tested 1,011 adults, and how many of them said yes? Can't remember what it was. 293. Thank you. 293 said football was their favorite. So when we do this, we're going to find our P hat, and we did this in example 1. 293 over 1, and this was 0.290, right? We're going to find our Q hat. This is 1 minus 0.290, so this is 0.710. Okay, we've got our P hat, we have our Q hat, we have everything that we need. Now, before we go on, we're going to have to test to see if N times P is greater than or equal to 5, and N times Q is greater than or equal to 5. Now, they did it in the book, so if you kind of just look in the book, they took your 0.29, they took your 0.71, and they multiplied it by 1,011. You can really see when your numbers are high, it is definitely going to clear that test. So, pick the one that's smaller, look at the smaller one, and yes, it did clear. So now, we're going to find your margin of error. Your margin of error says, take your ZC for 95%. 95% does not go in here. You need to find the ZC associated with 95%. This is your P hat, Q hat, so we've got 0.29 times 0.71 over, this time everything is inside this square root sign, over your N. Okay, now, anybody remember how to find the ZC?
Inverse norm.
Inverse norm. Okay, but you have to remember, we have to say, this is 95, and you already did it. Taylor already separated it. This is 5%, so half of 5 is 0.025. If you want inverse norm to do it, make sure you just put parentheses. 1 minus 0.95 divided by 2. Remember, when it comes out negative, we take the positive. We use the positive. In the margin of error, it kind of doesn't matter, because what's happening is, if you use the negative or the positive, you're still adding and subtracting the same thing, so it doesn't really matter. So we put 1.96 in here. We do not put 0.95 in there. 1.96, the Z-score. So you put that in your calculator just like you read this, and your margin of error, remember, is going to be small. You're dealing with proportions. And then you build your confidence interval. You do P hat plus or minus 8. So your P hat is 0.29 plus or minus 0.028. You're going to take 0.29 minus 0.028 and 0.29 plus 0.028. So it's going to build your confidence interval. And again, if you kind of look at your book, they use a number line again. A number line kind of tells you where to go with this. I like the use of their number line, because then you can see if you change your confidence interval, you can see it widen, you can see it get narrow. Here's your interval. what this is saying is this. There's my population proportion. I'm going to be 95% confident that my population proportion for those people that watch football will fall between 26.2% and 31.8%. If I was able to look at the entire population, I would be 95% confident that that proportion is going to fall between those two numbers. This is my inference. This is my inference that my sample makes about my population. That's why we do this. Instead of picking one number, 0.29, 29%, I have a little bit more room here. I get a to and a from. It gives me a little bit more leeway. Some 26 to 32%. That's a good range. But I have to be sure my population will do that. Now, in your calculators, for those of you that like your calculators, you're going to go to stat, you're going to go to test, and you only have one proportion. It's a one proportion z-test. They need the x and the n, and they need your confidence interval. When it comes back, it actually gives you the p-hat. So when you do the calculate, if you don't know your x and n, and you were given just your p-hat, you're going to just have to multiply it and get your x. But you have to remember, x always has to be a whole number. So you're going to have a little rounding to do. So if you like your calculator steps, it follows the same way the other ones do. When you find your interval, if you take your highest one and you subtract your p-hat, and your calculator will give you your p-hat. This will then give you your margin of error. That will give you your margin of error. The same way we did the other ones. You can kind of bypass all this information. All you need to do is get this. That's all you need to do is take that out of your problem. And the rest of it, your calculator does. I really do like the calculator for the intervals. Because, I mean, it's good to know. I like to try, walk them through. It's good to do, and I'll always do the formulas with you. It's good to know how to do them in the calculator as well. So you guys try it yourself too. Okay, so we're using the data from example, try it yourself 1. This is the people that liked Roosevelt, right? So what was your X? Sorry? 1177. And what was your N? 3859. Thank you. So your p-hat, therefore, is x over n, part over whole. What happened?
We did like the we just did. Yeah. Example 2.
I did it right.
Try it. It's try it 1.
Yeah.
It was from try it 1. As long as you did that and you did, as long as you got the concept of it, you're fine. So our p-hat was 305, right? And therefore our q-hat was 695, right? Okay, so remember, first thing you got to do is do this test. And the test works. When your numbers are that large, the test usually works, unless it's a very, very small percentage. But your percentages are fairly good size. Okay, so now, margin of error says ZC, P-hat, Q-hat, over N. So what is your ZC for 90%? 1.645. Good. And your P-hat and Q-hat go on the top in your numerator. Over 859. Make sure you use the right end. I know some of you sometimes are off on the end a little bit. So what's our margin of error to 3 decimal places?
How do you get 1.645?
You take this, you find 90% in the middle, so the leftover is 10, and you got to split it to 5%. Or let inverse norm do it, Alyssa. Go like this. 1 minus, make sure that's in parentheses, and let inverse norm divide it. You can put that right into that inverse norm. So this became 0.012,
Yeah.
right?
Yeah.
Okay, so p hat plus or minus e, 0.305 plus or minus 0.012. See how small your margin of error is? You're only dealing with a proportion, and it's a pretty small proportion. So your p hat's not going to be that large. So 293 to 317. Thanks. All right, and again, you're going to be 90% confident that your population proportion is going to fall between 29.3% and 31.7%. That's why you do all this. You infer this information about your population. Questions?